Okay. Okay. So right now I want to go over helium and zircon crystals. And I will say from this slide, genetic degeneration, we did talk a little bit about that. So that's good. Original organic material in dinosaur fossils, that's another one that the evolutionary community simply can't explain. I mean, how are these original bio materials, okay, how are they intact if dinosaur fossils really are millions of years old? I mean, they're finding in basically every single layer, they're finding collagen, red blood cells, proteins, DNA. They're finding DNA in Neanderthals that are supposed
What
to have
would you
gone.
say on a layman level out of these? I would say dinosaurs would be the one where you hear the most from it because I've got a whole family full of skeptics. So the one area that I think trumps or tricks people over with a young Earth is because of the dinosaurs. So I would love to do in the next session on just
Oh,
dinosaurs, something that I can just
and that's
because
one of my favorite. You know, we did a conference recently with Institute for Creation Research and a couple other ministries, Genesis Apologetics and the Grand Experiment. Dr. Brian Thomas, he's a scientist for ICR. He published recently, I think it's Analytical Biology. There's over 120 papers now in the conventional literature going over these biomolecules found in many fossils. It does
mm,
not coincide well at all with the conventional ages of dinosaurs and the geologic record in general. And because these biomolecules, they would have degraded, collagen would have degraded, DNA would have degraded. We should not be finding intact collagen and proteins and soft tissue in these fossils. So that
no,
tells us that these dinosaurs
definitely.
are young. They went extinct just thousands of years ago, not millions of years ago.
We've got stories. We've got stories of attacking Beowulf and look China. There's little pictures of dragons everywhere. I mean,
That's right. We've got depictions of dinosaurs in just about every single civilization. We've got stories from Alexander the Great, Herodotus.
yeah,
We've got stories,
that would be a very fascinating episode
and we
number
could go
two.
over the pictures,
Yeah,
even in
let's
the
do that.
Bible. Job 40 and 41, Behemoth, tail
Yeah,
like a
this
cedar tree,
tail like a cedar tree. That's
Leviathan.
not an elephant.
No, not an elephant, because that little wet noodle, that is not an elephant or a hippo or a bull. Some are trying to say that it's a bull too.
And out of the full strength in the loins. I mean, that's just
Oh, it's amazing. You know, we've done many shows on Behemoth that your audience can check out. But yeah, we can do a whole one on dinosaurs.
sure.
This one,
Sorry.
oh no, you're doing great. I want to wrap up with this one, and then we can focus on the other ones in another show. Because this here, it's technical. I'm going to break it down though in a few minutes, over the course of a few minutes. This is an irrefutable line of evidence. This is one of those lines of evidence that's not agnostic. It's discriminatory data that precludes an old Earth. Okay. And so helium in zircon crystals. What are we talking about here? Well, when it comes to these decay processes, Andy, we have uranium, right? Uranium to lead, potassium to argon, for example. When it comes to this, these helium and zircon crystals, we have uranium turning to lead. Okay. And during this process of uranium becoming lead through radioactive decay, you have helium, which is a gas. It's a slippery gas, slippery molecule. Helium is produced a certain amount throughout the nuclear decay that's occurring in the zircon. And helium can actually move through rocks since rocks are porous. And that means gas can escape through the rocks. Okay. So if we're on the same page, helium is produced, but it also escapes into the atmosphere as it's being
Hmm.
produced. Okay. Now, here's the thing. We do find evidence in
And
these
helium
zircon.
is produced in zircon, decayed zircon.
That's right. Yeah. As your uranium is decaying into lead, as
Yeah,
that process is taking place, you're having helium as a byproduct also being produced.
sure. Okay.
But the helium, it's a slippery molecule and it releases into the atmosphere over time.
Hmm.
Okay. And so we find rocks that have evidence for uranium, lead, and an abundance of helium as a byproduct. So since we're taking this slowly, that means uranium has been decaying into lead, because we find uranium and lead, and we're finding a lot of helium. So that's evidence that radioactive decay is happening. Uranium has been decaying into lead, and uranium is the result. It's a byproduct.
And
Now,
the decaying is like an unstable atoms, yeah? Is that how decay is measured?
yes, because you have parent isotopes and daughter isotopes. So you have stable isotopes and unstable. And so that's why you have uranium slowly decaying in that instance into lead. You could have potassium decaying into argon, right? There's different types of decay methods. And so in this instance, you have, through this process, you have helium that is being created, but also leaking out. Now, here's where it gets fascinating. This is truly one of the best lines of evidence for a young Earth. Okay, so you have helium that's being released, but the evolutionist camp, they're saying that this process of decay, uranium to lead, is taking millions to billions of years. As a matter of fact, these zircon crystals here, okay, here's the image that we made through AI. So cool. You've got the zircon crystal with the helium leaving, right, over time. And so they'll say that, okay, this is happening over hundreds of millions of years. Well, what does this mean? We understand the rate as to which helium will leave into the atmosphere, dissipate. Okay, that means over hundreds of millions of years, we'd have plenty of time
There should
for
be
all
enough.
that helium to
You
leak
can
through
measure
the
the
rock.
amount of helium in the atmosphere.
Right? Yep. You compare with the atmosphere, look at the rocks, how much uranium to lead decay has taken place.
So in terms of the age of the Earth perspective, sorry to cut you off.
Oh no, that's good.
So could you tell, you can measure the amount of helium based upon the age of the Earth and calculate there would be more helium? Is that where you're going?
Well, they're going to say that because of the amount of uranium and lead that we have, when they date those rocks through uranium to lead decay, those rocks must be billions of years old because of the amount of lead that's there. So there must have been this amount of uranium to lead. But is that really the case? Well, helium moves through these rocks quickly. Again, it's a slippery molecule. And so over millions of years, if these rocks really were millions to billions of years, Andy, that means all of that helium would have more than enough time to leak and escape into the atmosphere. But we actually find an abundance of helium in all of these rocks, in these zircon crystals. But if this process was taking place over billions of years, then
there would be less.
There'd be less. Exactly. We should not find the amount of helium that we actually do find, because we can measure this process as to how quickly helium can move through these rocks.
Evaporated.
Exactly, and be evaporated. And so we find an abundance of helium, where if these rocks really were billions of years, no, you should have very little helium because it's still decaying. So you're going to expect a little bit of helium, but not the overwhelming amount that we do find. Dr. Russell Humphreys, here's a paper. It's a technical paper. There was a team called the RATE team, the RATE project, Radioisotopes in the Age of the Earth. Several young Earth creation scientists went into this project to test the validity of dating methods. They made predictions, and this was one of the pieces of evidence that they discovered, that helium diffusion rates support accelerated decay. Now, why it says accelerated decay, I'll explain in a second, but I want to go through this citation. This is Dr. Russell Humphreys himself explaining it. And so notice this: uranium and thorium generate helium atoms as they decay to lead. A study published in the Journal of Geophysical Research showed that such helium produced in zircon crystals in deep, hot Precambrian, so that is like just hundreds of millions of years old. You got Precambrian, Cambrian, and then up to where we'd be today. So they say that's just a long time ago. Hot Precambrian granitic rock has not had time to escape. Though the rocks contain, this is an important point, though the rocks contain 1.5 billion years worth of nuclear decay products, right, the uranium to lead,
Mhm.
Newly measured rates of helium loss from zircon show that the helium has been leaking for only 6,000 years. Brother,
Awesome.
this
That's what I
is a
was getting at with my first.
scientific data point.
Yeah.
Go, go, go,
Yeah.
go ahead, go ahead.
But that was what I was trying to very poorly get. Like that was going to be your your conclusion. That is basically, you know, measuring the helium loss, and based on the loss, you can measure how old you. That was what I was trying to.
Yes, right.
Sorry, you
No,
misunderstood me because I'm not
no
very
need to be
smart. But
sorry. You nailed it.
that's kind of where I was going with that. Yeah.
Well, you were going in a direction that is accurate because the rapid rate
Yeah.
of helium diffusion suggests that the Earth, based on leakage rates, can only be 6,000 years
Yeah.
plus or minus a couple thousand. Okay, 6 to 10,000 years. But there's two pieces of evidence here. Okay, so I'm going to explain this the best way
But it
that I
ain't
can.
millions. That's the point.
Right, it's not billions, that's for sure. And it's a major point because you'll find a lot of theistic evolutionists and old Earth creationists. They'll say, oh, you guys love to point to supernova remnants or the decaying magnetic field or C14. C14 decays so rapidly, Andy, that we should not find C14 in samples that are supposed to be millions of billions of years old, like
Absolutely
diamonds
not.
or coal. But yet we find C14 basically anywhere you look in the
It should have been
geological rock.
decayed
It
by
shouldn't
now.
decay, shouldn't be there. We shouldn't be
Yeah.
C14 in diamonds. Shouldn't be C14 in coal. The half-life is way too short.
Isn't the half-life of a C14 about, is it 4,500
close.
years?
5,600
Oh,
years.
56. Sorry.
Yeah. So
It's been a while since I watched the seminar.
no, you're close. And
Yeah.
if every single atom in the universe were made of C14, there should be no C14 left in 500,000 years. Yet we find C14 in just about everything that's tested. So we point to these lines of evidence, the recession of the moon, the fact that the moon's moving further from us over time, that limits the age of the universe. And they'll say, okay, well, that just limits the age of the universe, but it doesn't actually give you 6,000 years is what they'll say. I want to see a scientific evidence that gives us 6,000 years. They'll challenge us. Well, here's one. This is helium diffusion and measuring the rates of helium loss from zircons. Andy, what does this say in this paper? It's only been leaking for 6,000 years. So the next time somebody says, show me a piece of evidence that gives me 6,000, here it is. 6,000 years based on a scientific piece. Mutation rates do the same. That'll also give them what they want. And so this is a piece of scientific evidence. This is an observation that offers 6,000, and they have no good explanation for this. But Andy,
you perfectly hit the brief, Donny. This is all the new stuff that I've got no idea about, right? So, and I think the audience have no idea about it. So this is hitting the brief, brother. So I really do appreciate it.
Hey, my pleasure. You know, there's a lot of creationists out there. There's a lot of creation ministries. And I spend a lot of time, I have over the years. I've personally done 100 formal debates myself, and I've moderated well over 400.
Yeah.
And I spent the years debating probably your most militant evolutionists out there on YouTube, especially. And so they like to use a lot of technical arguments. And so what I've done is countered them largely through technical arguments, fighting fire with fire. And that does require a lot of study and research. Thank God I do this full time. My main area of study is genetics and biology, but I do what I can on these various subjects as well. So I like to latch onto your pieces of scientific evidence, Andy, like this, right? Helium diffusion, helium and zircon crystals that I know they have not even a good rescue device for. Not even a good maybe this or maybe that. No, they literally have.
Could they say obviously they would have said it. Could they say that it's only showing 6,000 years? We don't understand why it started diffusing at that point in time.
Well, they could say we don't know because of XYZ, but it's not really science. That's
no, it's not science,
right
but it's
to believe.
Yeah, because you can't say that zircon came into existence just 10,000 years ago. You know what I mean?
Yeah, well, exactly. They're gonna have because when not only
Because everything came
believe.
from the Big Bang or that big explosion.
Exactly. I mean, as humans, we're just recycled stardust, right? All the matter and energy
Yeah,
and
yeah,
material in the world was basically squeezed into a dot smaller than a single period on a piece of
yeah.
paper. So everything to them has evolved.
It's
Nothing's really
remarkable,
been
Donny.
created. But to us at creation, there were created trees, created rocks, humans were created, animals were created. So we have no problem saying, hey, diamonds were created, zircon crystals were created, granitic rock was created. There's all kinds, trees were created.
Mm.
Okay. And so, they can't obviously admit to that. But why this is also important, because if you notice in this citation here, we do have evidence that decay has occurred, uranium to lead, because there is lead. Okay, so this is interesting. Think about this, Andy. We have uranium, lead, and a lot of helium. So it almost looks like we have evidence for an old Earth and a young Earth in zircon crystals, because we have uranium to lead. This nuclear decay has happened, but yet we have a lot of helium. So what the rate scientists concluded, at least, and I think it's a pretty good conclusion. There are other ways you can look at this, but one easy way to look at it is during the flood year, right? The flood catastrophic processes would have released a lot of heat, energy, and radiation, but heat and energy. And during that flood year, many in the creationist world, they've suggested that there was an accelerated decay. So radioisotope decay was accelerated, but it was only accelerated for a short period of time, which is why you find uranium and lead. Okay, but because we find the abundance of helium in the zircon crystals, that suggests that, okay, you had a lot of decay quickly, and it had to be quickly, or else that helium would have escaped into the atmosphere. So does that make sense? We have a lot of helium, but also a lot of decay, which suggests that there was a lot of decay, but that decay happened rapidly during the flood year. Does that make sense, brother?
Mm-hmm. Mm-hmm.
And so if you've ever heard accelerated nuclear decay before,
No.
that's okay. Well, right there would be that would be, because here's the thing. The next question is, the evolutionists will say, well, why do lower rocks in, say, the Precambrian, why do they date older than higher rocks? Okay, why are there these patterns? Well, if accelerated nuclear decay is true, and you have rocks being laid down during that flood year, but these rocks are being subject to different degrees of accelerated nuclear decay based on this and many other pieces of evidence, well, that means rocks that are laid down earlier in the flood, they're going to experience more hits or rounds of accelerated decay than rocks laid down later in the flood year.
Why?
So yeah, those earlier rocks will date older than rocks that are formed later because they were hit with more rounds of accelerated decay. So sure, we could have relative ages. You can say those are billions of years old. That's just relative, though. That's not absolute. So that would be that would be your technical follow-up to an informed evolutionist that says, okay, fine, helium and zircon crystals, or C14 in coal diamonds and dinosaur fossils. But why do the lower layers date billions of years and your higher layers, they date less? Well, there's a reason. Accelerated decay during the flood year. And they'll say, oh, there's no evidence for accelerated decay. Well, firstly, in the lab, they have sped up nuclear decay rates. And secondly, here's a piece of evidence.
So
How
why
is there
wouldn't
so
it?
much helium in these zircon crystals if these zircon crystals really go back billions of years? They have no good answer. Andy, go ahead, brother.
Why would there be? Why would the accelerated decay rate be faster in rocks? The
Well,
first layer.
well,
I mean,
so
maybe. Sorry, I shouldn't keep asking questions. I should just shut up.
no, you ask whatever you need. These are great questions. I did a whole series with a flood researcher called Flood Boundaries, Michael J. Ord. So this goes into a whole nother technical topic
Okay.
of where the flood boundaries, because obviously you have created rock, right?
Mm,
And then you have the flood. So you have new rock being created plus the
sure.
shuffling of pre-existing rock. But then
Yeah.
you also have rock produced, sedimentary rock layers produced, and geological features created after the flood, right? Because after the flood, you have a post-flood ice age that lasts 500 to maybe 800 years. You have local catastrophes happening after the flood. So you actually have pre-flood boundaries, flood boundaries, and post-flood boundaries. But in terms of the flood layers, you'd expect rocks that are formed early in the flood versus later in the flood, you'd expect those ones laid down earlier in the flood to date older because they experience more accelerated decay than rocks laid down later in the flood. They would experience accelerated decay, but less of it because less period of time, right? Does that make sense?
Right. Okay. Yeah. It's better. Yeah. We
And
can
so
touch on that next
that would explain your patterns. But they have tested newly formed rocks, okay? Because you have igneous rock, right?
one.
Formed through volcanic eruptions. They've tested these rocks. We know when they were formed, right? A short amount of time ago within our lifetime.
They've dated way back.
Yeah, they're dated. They're dated at hundreds of thousands to millions to billions of years. It's like, well, wait a
In
minute.
any other discipline, that would immediately be discredited.
Be
If you're
thrown
talking
out.
about it, it'd be thrown out. Like if you talk about law, that type of level of discrepancy would be thrown out. Totally. But they can't because the consequences is completely different. So,
Well, and
or
that's the thing.
it leads to a conclusion that I don't want.
Well, and that's the thing is the evolutionary community, they believe in science until supposedly they believe in science until you show them these kinds of observations. Now they no longer believe in it. And I like to ask this question, Andy. Okay. Why should I trust the dates that you give us from rocks of unknown age? Oh, this rock here is 500 million years old. This rock here is 2 billion years old. Wait a minute. You can't even give me accurate dates for rocks of known age. So therefore, why should I trust the dates that you're giving me from rocks of unknown age? Clearly, these dating methods don't work.